Understanding how the moon has developed would really help us in understanding how the other planets in the inner part of the solar system, the rocky planets, have also developed. The purpose of the GRAIL mission is to investigate the interior structure of the moon. To achieve that, we have to measure the gravitational field of the moon.
So we're all familiar with tides on the Earth that are caused by the moon. The moon actually has similar tidal response. And when the moon changes its shape a little bit due to those tides, just like the Earth does, we can actually measure that. That affects the gravity field. As the lunar shape varies, its gravity field changes, and we're able to observe that.
We are using a very simple measurement, which is gravity. It's a little bit like taking a CAT scan of the moon, but using gravity waves instead of acoustic waves to unlock the secrets of the interior of the moon. We have two spacecraft that are in a polar orbit around the moon. One's essentially chasing each other around the moon.
There's a part of the Earth's moon, a very significant part, the far side of the moon, that does not present its face to the Earth. So we can never directly observe the spacecraft as it goes across the far side of the moon using Earth-based tracking antennas. So the solution to that was, rather than track the motion of the spacecraft as it's orbiting the moon from the Earth, track it with another spacecraft also orbiting the moon.
It's essentially the same technology as the GPS in your mobile phone. And in fact, the two orbiters together form sort of a mini GPS and receiver constellation, except using different frequencies from normal GPS.
The first thing we do actually, once the map is in our hands, is compare it with a topography map, hopefully of comparable resolution. And from there, we can look at specific features, such as mountains and basin craters, and compare the gravity and the topography. This is where it gets really interesting. You would normally think that if there's a mountain present on the planet, there's additional mass and additional gravitational signal as the spacecraft flies over it. But if it does, and there is no additional gravity signal, then something on the inside is going on that is particularly interesting. And that's what we want to know.
When I was just getting into middle school, I had to rely on my information on the moon watching the Apollo missions on television. We wanted students to have a hands-on role in exploring the moon. It's an experiment called MoonCam. We will have up to 4 cameras on each GRAIL spacecraft. Students will be able to look at the ground track of where GRAIL will be at going around the moon on a daily basis and to propose images that will be taken. It's going to go a long way towards helping students understand just how much fun science and engineering is as a career.